Next problem, next application of the quadratic function. This classic problem, which is sometimes called the garden of maximum area problem or something like that, okay? It doesn't have a precise name, but this is a classical problem. Okay, what is this problem about? So you have your backyard and you want to create a garden here and you want to enclose it, okay? You want to use this thing which is known as mesh wire, these things that we use for putting chickens inside. It's this thing, okay? This kind of wire. This is called mesh wire. So you're gonna buy some of this because you want to enclose the garden, okay? And you're gonna create the garden in such a way so as to have one of the sides of the backyard. Let's suppose that this has like a fence, so all of this is fence, all the backyard. And so you're going to use one of the sides of the backyard as a site for the garden in order not to waste too much material, okay? So basically you want to put your mesh wire in this way. Some in here, some in here, and some in here. And here inside will be your garden, okay? So this is mesh wire, and mesh wire. Okay, and you go to the hardware store and you're gonna buy 20 meters, let's suppose 20 meters of mesh wire. That's all you got. Okay, and then you face the following problem. Once you get to your backyard and you try to put your mesh wire in such configuration, okay, you face the next dilemma. In what way do you have to put the mesh wire? Like what do these dimensions need to be? X, of course they need to measure the same, right? Because we're talking about a rectangle. And Y, what do these dimensions have to be, X and Y, in order for the garden to have the maximum area possible? Because it's gonna be different if, let's suppose that I have the same backyard here and same backyard here. If somebody does the following, for example, if some person decides to create the garden this way, first of all it would look very weird, okay? But this, okay, like this and this and this is all your mesh wire and it amounts to 20 meters. This probably is going to have a different area than perhaps doing something more of a squarish shape, right? And being this equal, right? 20 meters, like this plus this plus this, which is your mesh wire, is 20 meters. In this case, it's going to be the same. This plus this plus this is going to be 20 meters, but maybe the areas will come out different, okay? And they will be different. For example, it's not the same if, let me exaggerate my point. If somebody decides to create the garden in this way, like I'm exaggerating, okay, this plus this can be 20 meters, but the area of something that is very thin, very slim, is going to be very small. The area of this thing will be very small compared, for example, with something like this. So in what way do I need to arrange my garden? In what way do I need to decide for X and Y, these dimensions, in order for this garden to have maximum area? That is my goal, for obvious reasons, right? I mean, it's gonna be better if I have a maximum area for planting flowers and all that stuff. Okay, so that is the problem. What do these quantities need to be, X and Y, in order for this garden to have maximum area? So we know what the problem is. Now let's try to solve it. Okay, how do we go about this problem? In the same way as before, we try to come up with equations, guys. Mathematics in this way, in this sense, when you work with problems of this type, you're trying to collect as much information as you can. and you're gonna try to write down as many equations as you can. Okay, that is the idea. And somehow you're gonna notice that those equations that you write will eventually help you in the solution of the problem. So let's start. What do we know? Well, very simply, we can use this fact already. We have bought 20 meters of mesh wire, and since the mesh wire is this little bit plus this little bit plus this little bit, then clearly we can write our first equation. X plus y plus x is going to be 20 meters, which for simplicity purposes, I'm going to ignore the units. Mathematics never uses units, okay? That's the realm of physics. In mathematics, we only talk about numbers. So if I simplify this stuff, I get 2x plus y equals 20. And this is my first equation that relates my quantities x and y, which are my quantities of interest. Okay, we have nailed down one equation. Perfect. Let's try to look for another equation. What else can we write? What other equation can we write? Well, if you notice, another quantity of interest is my area. What is the area of this rectangle? It's going to be x times y because it's a rectangle, right? So it's basically base times height, y times x, or x times y. It's going to be, it's the same, right? X times y. And I'm going to call this my second equation. So I now have other equation. So we have this equation, number one, and an equation number two. Now, the trick for solving this problem and many other problems which are similar to this one is the following. Again, I'm going to try to combine my two equations in the following way. I'm going to isolate y. From this equation, I'm going to isolate y. I can also isolate x, okay, no problem, but I'm going to decide for y. So it's going to be 20 minus 2x. This is my isolation. And since y is equal to this, I'm going to take this, which is y, and I'm going to plug it right there. You see, so I'm combining my two pieces, my two equations. I'm combining them. So let's do it. I'm going to get that the area is equal to x times y, which is this. And look at what's going to happen. A equals 20x minus 2x squared. And if I arrange these terms, I get minus 2x squared plus 20x. And look at just what happened, guys. Look at this equation. It says the area is equal to minus 2x squared plus 20x. What is x? X is one of the sides of my garden. And if I know how to read functions, and if I understand the concept behind function, I can say that the area of this thing, of this garden, is a function of x, right? Look at this. The area depends on x. If x changes, if my input changes, clearly my output will change. And that is the whole thing about functions, right? You change one variable and you get an output as a result, so to speak. Okay, so a is a function of x. Let's write that in mathematical terminology. I'm going to do it in yellow. So a is a function of x. What function? This one. F of x equals minus 2x squared plus 20x, where f of x is the area. The function f of x is giving me the area as a function of my side x. And now I'm just going to use this thing to solve my problem. Why? Because being a function, a quadratic function, we know that this is going to look like a parabola, okay? And I think I have already told you the fact that we have a minus, that the fact that the coefficient in the x squared is negative. What that means is that the parabola, when you graph the parabola, is gonna go downwards. Okay, it's gonna open up downwards in like this way. Okay, why am I starting at 0 right there? This is, by the way, this is x and this is the function. Why am I starting at 0? Why am I saying that for x equals 0, f of x is 0? Because that's what I have in here. If I put 0 in the x, what am I gonna get for f of x? I'm gonna get minus 2 times 0 to the square plus 20 times 0, which is 0, right? So for x equals 0, f of x is 0, and so that's why this point belongs to the graph, which makes sense intuitively, because if this side goes to 0, I have no garden basically, and no garden means no area. Okay, so again, one more time, what does this represent? It represents the area of the garden, you see, and x represents this side. So according to how this function behaves, how can I interpret this graph? Well, I can interpret it in this way. As the side x grows, as it grows in this way, what I'm going to observe is that the area, which is f of x, is going to grow at first, and there's going to be a point right here of a precise value of the side x, right this value, for which the area will be maximum. And then after that value of x, if I go more to the right, I'm gonna get a diminishing value for f of x, in other words, for the area. You see? So tell me guys, what is this point? It's the vertex, right? If I find the coordinates of the vertex, if I find this value and this value, then I'm done, because I would be telling, if I can find this precise value, I'm saying that for that value of x, I'm getting the maximum area. And that is what the problem is about. It's about finding what values of x and y give me the maximum area. So let's find out the vertex for this particular function. How? Let's use the formula. Okay, the vertex has coordinates vx, vy, where vx is minus b over 2a. What is b and what is a? They're my coefficients in my function. So b in this case is minus 2. No, I'm sorry. It's 20. So minus b is minus 20 because b is 20. Over 2a. How much is a? It's minus 2. So I'm going to get 2 times minus 2, which is minus 4. And then minus 20 over minus 4, that gives me 5. So this number, guys, this coordinate of the vertex is 5. This value is 5. And now what is this value? Is the function evaluated in such a number. So this function evaluated in 5, I'm going to get f of 5, which is going to be minus 2 times 5 to the square plus 20 times 5. So I'm gonna get minus 50 plus 100, which is 50, right? Yes, it's 50. So this other coordinate is 20. No, I'm sorry, it's 50. So what does this say? What does this mean? That means the following: for a value of x, when this side measures exactly 5 meters, I'm gonna get maximum area. What maximum area? 50. and I have solved the problem completely. Now the rest is just finding y, but that is very simple, right? Because I have in here, for example, look at this equation, 2x plus y equals 20. Now that I know x, which is 5, I just put it here, 2 times 5, it's going to be 10. And so if this is 10, then y has to be 10, right? In order for 10 plus 10 to be 20. So I have already found y. So conclusion, let's conclude the problem. X equals 5 meters of mesh wire and y equals 10 meters of mesh wire will give me a maximum area of 50 meters. Okay, so the dimensions of the garden have to be 5 and 10 meters in here. And if you notice, it makes sense because 5 meters plus 10 meters plus 5 meters is going to give me the initial 20 meters of mesh wire. So that's how you solve this problem. If you want to convince yourself, plot this on Desmos. Let me do it very quickly. Minus 2x squared plus 20x. Minus 2x squared plus 20x. And let's look at the function. You see, it's a parabola that opens up downwards. It starts at 0 and its vertex is the point 5, 50, like I told you. What represents the x? What does this axis represent? The side x. What does this axis represent? The area of the garden. So for a value of x equals to 5, the area of the garden is 50 and it's maximum, right? Because for anything to the other side, you see, the area is decreasing, and anything to the right, the area is also decreasing. So this is your maximum value. So that's how you use mathematics, guys. It can help you create things with uh, maximum areas and stuff like this. And if you think that this is like irrelevant or something, no. I mean, engineers, when they design stuff, for many cases you want to maximize areas or volumes, etc. Okay, because I mean, for a farmer, this is ideal. A farmer needs maximum areas to plant stuff and all these things. Okay, so these are not just textbook problems. These are actually problems that are solved in real life, and many industries and economies depend on the well-doing of these type of problems.